Okay, so before starting, let's discuss some features of Auricle. So in Auricle, we provide the live classes to elevate the learning of the student, and also we provide the recorded session. So if any student have missed any class, so recorded sessions for all the first year student can have anytime, anywhere through the recorded session. And the classes the student can take, and also we provide notes with CBME based question answers MCQ and full zone for self-assessment, and also MCQs are there from beginner level to expert level. Then also we provide a slot. You can also book a slot for personalized counseling session in which the student will have the direct interaction with the counselor. So these are the topics that will be covered in today's session, starting from Brown-Stewart syndrome, internal capsule. Then we'll discuss physiology of memory, slow wave sleep, and inverse stretch reflex. Then Kluver-Bucky syndrome. Then mechanism of conduction and saltatory, and phantom limb we're going to discuss. So these are the important topics of CNS that we're going to discuss in today's class. So first, we're going to discuss the mechanism of conduction and saltatory. So before starting this topic, we should first learn that what is conductivity. So what is conductivity? The conductivity is the ability of nerve fibers to transmit impulse from the area of stimulation to other areas, right? So the mechanism of conductivity already we have discussed in the last class. So whenever the action potential is transmitted through the nerve fiber, right, as the nerve impulse, normally the action potential transmitted through the nerve fiber in only one direction, right? In only one direction is going to transmit. Uh, um, so in experiment condition also, when the nerves are stimulated, the action potential travels through the nerve in either direction. So in today's class, we're going to discuss the mechanism of conduction and saltatory. So the conduction through myelinated nerve fibers is known as saltatory mechanism. Okay. So first we should learn the significance of saltatory conduction. So saltatory conduction is basically responsible for faster conduction. Okay, so this conduction is responsible for faster conduction of impulse. And the conduction of impulse through the myelinated fiber is about 50 times faster than the non-myelinated fiber. So if we compare myelinated and non-myelinated fibers, so always remember the conduction is always faster in myelinated fibers, and that is 50 times more, right? Now, why this happened? Because it is because of the action potential that jump from one node to another in node of Ranvier instead of traveling through the entire nerve fiber. Okay, so this is the significance. Now when we talk about the mechanism, so myelin sheath is basically not permeable to ions, so that the entry of sodium from extracellular fluid into the nerve fibers occurred only in the node of Ranvier, where the myelin sheath is absent. And why this happens? This happens because of the depolarization in the node and not in the internode. So the depolarization occurs at successive nodes, so that the action potential jump from one node to another, and that's why this is known as saltatory mechanism. Okay, so all the students should remember that saltator means jumping, and the saltatory mechanism, or we can call saltatory conduction, occur in myelinated sheath only. Myelinated nerve fiber only. And this is the faster way of conduction. Okay, so this is all about the mechanism. Now, next we have frontal limb. So before going through this frontal limb, we should also understand the law of projection. Okay, so in the last class also we have discussed the law of projection. So what is law of projection? When a sensory fiber or when a sensory pathway from receptor to cerebral cortex is stimulated on any particular site, along its course. So the sensation caused by stimulus is always felt, or we can call it always referred at the location of receptors, irrespective to the side of stimulation. Okay, so this phenomenon is known as law of projection. Now, several examples we have discussed in the last class. So, if some, just one example more, we are going to discuss about law of projection. So, sensation complained by amputated patient, right, in the missing limb. So that is phantom limb. Okay, missing limb. So this is the back's example of law of projection. Okay, so phantom limb is the example of law of projection. So if a leg has been amputated, the cut end heals with scar formation, and the cut ends of nerve fibers are merged within the scar. And if the cut ends of sensory fibers are stimulated during the movement of thigh, right? If the movement will be there, then the patient feel as if the sensation is originating from the non-existing. So if this part has been amputated, so the sensation, the patient will if the sensation is originating from this non-existing leg. Okay, and the sometime the patient feel pain in the non-existent limb, and this type of pain is known as phantom limb pain also. Okay, so this is all about the concept of phantom limb. So we can write down for recap that phantom limb pain is the sensation complained by amputated patient in missing limb. Okay, so if the cut ends of sensory fibers are stimulated during movement, the patient feel as if sensation originating from non-existent leg. Okay, now next we have the another topic, that is Brown Sequard syndrome. Okay, and also this is the important topic, and usually the question comes from this topic. Okay, so what is Brown Sequard syndrome? This is also known as hemisection of spinal cord. Okay, so the lesion involving one lateral half of spinal cord is known as hemisection. Okay, and it can occur during any type of injury, any type of accident. Okay, and also it can be produced in the experimental animals also. So what is the symptoms of Brown Sequard syndrome? So as we can see in the picture also, this is a condition which is associated with hemisection damage to half of the spinal cord, and basically it causes the loss of various sensations, right, like the sensation of pain, temperature, touch, and also it can lead to the paralysis or loss of muscle function, right? So the sign and symptoms which occur after the hemisection of the spinal cord, it basically constituting the Brown Sequard syndrome. Okay, now if the section is due to the injury, spinal shock occurs immediately. So this is the immediate one, that spinal shock will come. Now muscle loss the tone and become flaccid also, and this reflexes are abolished in the case of the patient, if the if any case arises, if the patient has survived, so the stage gradually pass off and the certain signs and symptoms can also develop. Okay. Now we're going to discuss that affect occurs at below the level of lesion and at the level of lesion. Now, affect in these areas differ on the same side as well as on the opposite side. So that we're going to discuss. So first we have below the level of lesion on same side. So first we going to that. So various changes are there. So first we're going to discuss about the sensory changes. Okay, so on the same side below the level of lesion, many changes are there, right? And these changes occurs because of the because these sensations are carried by the uncrossed fibers of the tract. Okay, so these changes like change in fine touch, tactile localization, sensation of vibration. Okay, so these are the changes and many other also like loss of consciousness, stergogenesis, crude touch, pain touch. Okay. Now, next we have the motor changes. So in motor changes resemble the effect of upper motor neuron lesions. For example, there will be increase in muscle tone, leading to spastic paralysis also, rigidity of limbs can occur. Also, the muscle wastage usually does not occur, and also the deep reflexes are exaggerated. Okay, now next we have below the level of lesion, opposite side. Okay. So again, we're going to discuss sensory changes and motor changes. So in sensory changes, on the opposite side, below the level of region, the following sensations that we're going to discuss are lost completely because these sensations are carried by cross spinothalamic tract. Okay. So this includes crude touch, pain, temperature. Okay. And in motor changes, we have mostly there are not be any paralysis of muscles, but if it occurs, it would be mild as only a few fibers of pyramidal tract are affected. Okay, so this is because pyramidal fibers cross the opposite side and paralysis is of upper motor lesion occur. Okay, so during hemisection of the spinal cord, the motor loss is extensive and sensory loss is less below the level of lesion on the same side. Okay, so on the opposite side, sensory loss is extensive and the motor loss is very less. Okay, now next we have very less changes we can write. Okay, now next we have the effect of hemisection or Brown sequence syndrome of spinal cord at the level on same side. So first, we're going to discuss about the sensory changes, and then we have motor changes again. So on the same side, at the level of hemisection, there is complete anesthesia. Okay, and that is all sensations are lost. Okay, and this is because of complete destruction of the posterior nerve root. Okay, now the motor changes. So effect of lower motor neuron lesion occur. The motor neuron and their fibers leaving the spinal cord are affected. Okay. So the motor changes of lower motor neuron are muscle loss, the tone, right, and become become flaccid, and also reflexes are lost. Okay. Now next we have the another, that is at the level of lesion opposite side. Again we have sensory changes, then motor changes. So in sensory changes, there is loss of pain, temperature, crude touch, right? So there will be loss of pain, temperature, and crude touch. And this is all, touch. This is all occur because the cross spinal thalamic tracts are affected, okay? Whereas in motor changes, no motor changes will occur, but if it occur, it will be very mild, okay? So usually no, not occur, but if occurred, they will be very mild. Okay, so this is all about the Brown Sequard syndrome and all the lesions that is occurs because of the effect of hemisection of spinal cord. Okay, now next topic we have the another top important one, and that is internal capsule. So what is internal capsule? Internal capsule is a broad, compact band of afferent and efferent fibers connecting cerebral cortex with brainstem and spinal cord. Okay, so basically this area is responsible for the connection between cerebral cortex with brainstem and spinal cord. Okay, now cerebral cortex is connected with brainstem and spinal cord by both afferent and efferent fibers, and also the fibers arising from different part of cerebral cortex descend downwards into the white matter of cerebral hemisphere in the form of radiating mass of fibers known as corona radiata. Right now, while passing down towards the brainstem, that corona radiata converge in the form of a structure, and that structure is known as internal capsule. Okay. Now, the fibers from spinal cord and brainstem reach cerebral cortex in the same route, and a large portion of internal capsule is formed by thalamic radiation. Okay. Now, talking about the situation of this internal capsule. So, this is located between thalamus and caudate nucleus on the medial side and reticular nucleus on lateral side, right? Now we're going to discuss about the some parts of internal capsule or about the division of internal capsule. Okay. So internal capsule, as we can see, it has two limbs, the anterior and the posterior. Okay. So in between two limbs, the lies the genu of internal capsule, and distal end of posterior limb is continuous as the caudal portion of internal capsule. And also talking about the internal limb. So what is internal limb? What is anterior limb? Anterior limb of the internal capsule is short and lies between the reticular and caudate nucleus, as we can see. Okay, so this lies between the lenticular or lentiform nucleus and caudate nuclei. All right. Now talking about the posterior limb. So this posterior limb is very long and also situated between thalamus and lentiform nucleus. Right. Now this genu is located between the anterior and the posterior limbs, whereas the last and the caudal part is situated between the caudal part is basically the end one, and it is known as retroauricular portion of internal limb. Okay, now we're going to discuss about the fibers of internal capsule. So the fibers we're going to discuss with the help of the anterior limb, posterior limb, then genu, and the caudal portion. Okay. Now, anterior limb has nerve fibers like anterior thalamic radiation, then prefrontal corticopontine, and the fibers from orbital cortex to hypothalamus. Whereas the posterior limb, it has fibers like cortico spinal tract, then superior thalamic radiation, then frontal corticopontine tract. Then in genu, we have only one, that is corticobulbar tract. Then in caudal portion, the nerve fibers arises like posterior thalamic radiation. Okay, so this is all about the internal capsule. Next, we have another topic and also the important one, that is known as Kluver-Bucky syndrome. Okay, so what is this Kluver-Bucky syndrome? This is the bilateral region of the temporal lobe, and the causes are different, and main is herpes simplex encephalitis, which is mostly responsible for affecting the temporal lobe, and it can also cause trauma, stroke, Alzheimer's, and which can lead to various metabolic condition that affects many organs, and that could all that those organs regulates emotions, reinforce behavior related to food and sex. Okay, so this Kluver-Bucky syndrome is also known as temporal lobe syndrome. Okay. And also, this is observed in various animals, particularly in monkeys, after the bilateral ablation of temporal lobe, along with many other structures. And it also occurs in humans during bilateral region of these structures. Okay. Now we're going to discuss about the manifestation of temporal lobe syndrome. Okay. So it can cause retrograde amnesia. Amnesia is loss of memory. Then aphasia. Then also it could lead to auditory disturbance. In auditory disturbance, such as frequent attacks of auditory hallucinations, or it can cause ringing on humming, then buzzing. Okay, so various disturbances it can cause. Then also it can lead to disturbance in smell and taste sensation. Then it can also cause visual hallucination, which is also associated with anopia. Okay, so this is all about the temporal lobe syndrome, which is also known as Kluver-Bucky syndrome. Now, next we have the inverse stretch reflex. Okay, so inverse stretch reflex, basically, this is the sudden decrease in resistance due to relaxation instead of contraction. Okay, when the muscle is stretched excessively. Okay, so we can call the inverse stretch reflex is the sudden decrease in resistance due to relaxation. Right? Whenever a muscle stretch excessively. Okay, so due to stretch reflex, harder a muscle stretch, the stronger is the reflex contraction will be there, and this is seen up to a limit. With further increase in stretch contraction, suddenly comes to an end and muscles relaxes. So this relaxation response to strong stretch is called as inverse stretch reflex or auto inhibition. Okay. Okay, so this reflex is also known as inverse myotatic reflex or the polysynaptic reflex. Okay, so the another name is inverse myotatic reflex. Okay, and this inverse reflex is actually the inhibition of contraction of extrafusal fibers due to excessive stretching. Okay, and this phenomena is also known as autogenic inhibition or autoinhibition. Right now, what is the mechanism of this inverse stretch reflex? So excessive stretch of the muscle which leads to activation of Golgi tendon organ. Right now, which send the afferent impulse and cause stimulation of inhibitory internnuncial neurons, which in turn inhibit alpha motor neuron of the stretch muscle, resulting in relaxation, and also the stimulation of excitatory neurons, which in turn activate alpha motor neurons of the antagonistic muscles, which can lead to contraction of muscles and relaxation of stretch muscles, right? So this is all about inverse stretch reflex. Now, next we have slow wave sleep. Okay, again, this is the important topic. So before starting with slow wave sleep, we should know what is sleep. So sleep is a natural state of rest for mind and body, also with closed eyes, right? And this sleep is characterized by partial or complete loss of consciousness, right? And as we know, the loss of consciousness leads to decreased response of external stimuli, and also the body will have decreased movement, right? And depth of sleep is not constant throughout the sleep. It can vary in different sleep stages. So there are many sleep stages. So sleep is one of two types: the non-rapid eye movement or the slow wave sleep, and the second we have rapid eye movement, or this is also known as REM sleeps. Okay, so in today's class we are only going to discuss about slow wave sleep, or this is also known as non-rapid eye movement sleep. Okay, so what is this sleep? This non-rapid eye movement sleep or slow wave sleep is a type of sleep without the movements of eyeball. Okay, so please remember, this is without the movement of eyeball. Okay, now why this happens? This is also known as slow wave sleep because there is a generation of slow waves, or we can call, there will be low frequency waves will be observed in this type of sleep. Right now, it occupies 70 to 80% of total sleep period. Okay, now also in today's class, we're going to discuss about the various stages of non-rapid eye movement sleep. So first stage we have stage of drowsiness. So what is this stage? Basically, while sleeping asleep and after going to bed, the person is in the state of wakefulness, right? That is while lying on the bed, right? Now the eyes are closed and the mind get relaxed. Then the person proceed to drowsy state, and during drowsiness, the person can be awakened easily. The muscular activity will get slowed down, right? And also some person may have the feeling of falling followed by sudden muscular contraction, and this period lasts for about 1 to 10 minutes. Okay, so next we have also in stage of drowsiness, alpha waves are appeared. Okay, now next we have the another stage, that is stage of light sleep. Okay, now what is the stage of light sleep? When the person goes to light sleep from drowsiness, right? From the stage of drowsiness, it went into the stage of light sleep. The heart rate will get slow down, the body temperature start decreasing, and also the body prepared to go into the deep sleep, and this period lasts up to 20 minutes, right? And in this stage, there will be appearance of theta waves. Okay. Now, the third stage we have initial stage of deep sleep. So what is this initial stage of deep sleep? This is basically the transition period. Transition period from the light sleep and the deep sleep. Okay, so this is considered as the initial stage or initial stage of deep sleep. Okay, now what happened during this stage? The spindle burst and K complex appears. So there will be appearance of delta waves with high amplitude. Okay, now finally we have deep sleep stage. So as we have discussed earlier, um, the third and fourth were separated. Now, nowadays, these two stages, the third and fourth, these two stages are combined together. And when the person entered into the deep sleep, it is difficult to wake up, right? If someone wake him or her up, there may be a feeling of disorientation for a few minutes, right? If the person will get suddenly wake from the deep sleep, so person will feel disorientated. And there also may be a feeling of like loss of consciousness for a particular time, right? And in spite of having high potential, right? The sleep disturbance occurs from the many things like arising of noise, or some person may sleep without any reaction. Okay. Now, talking about the EEG pattern that occurs. So in during this stage, the delta waves again appear and become more prominent, but with low frequency and high amplitude. Okay, so this is all about the stages of slow wave sleep. Okay, now next topic we have the physiology of memory. So I think also the about memory we have discussed in the first class of CNS. So memory is defined as the ability to recall past experiences or information, right? And it is also defined as the retention of learned material. So there are various degree of memory. Some memories remain only for a few seconds, right? While other last for few days, for few hours, few months, or for few years. Okay. So talking about the anatomical basis of memory. So anatomical basis of memory is the synapse in brain, right? So synapse for memory coding is slightly different from other synapses, and two separate presynaptic terminals present. One of the terminal is primary synaptic terminal, which ends on the postsynaptic neurons in conventional synapse, and this terminal is also called as or known as sensory terminal, right? Because sensations are transmitted to the postsynaptic neuron through this terminal. Okay, and another one we have the presynaptic terminal and on the sensory nerve itself. With this terminal is known as facilitatory terminal. Okay, so whenever sensory terminal is stimulated um, along without facilitator terminal, the firing from sensory terminal leads to habituation. Habituation is the firing decrease slowly. On the other hand, if both the terminal are stimulated, then facilitation occurs and the signal remains strong for long period, that is for few months to few years. Okay, so this is all about the physiology. Now we're going to discuss some functional status of brain with the physiology of memory. So in this we're going to discuss various concepts like facilitation, then what is habituation, then short basis of memory, short term, actually, I should write short term basis of memory, then long term basis of memory, and last we're going to discuss the sites of encoding. So what is facilitation? This is the process by which memory storage is enhanced, and also it involves increase in synaptic transmission, and there will be decrease in postsynaptic activity, right? And often the facilitation is refers to as positive memory. Okay. So this is also known as positive memory. Okay, now next we have habituation. So this is the process by which memory and storage is attenuated, right? Attenuated means there will be decrease in strength or in decrease in strength or value. Okay, so it involves reduction in synaptic transmission, and there will be slow stoppage of post-synaptic activity. Okay, so that's why the habituation is also known as negative memory. Right? Now we're going to discuss the basis of short-term memory or short-term basis of memory. So basic mechanism of short-term basis term memory is the development of new neural circuits by the formation of new synapses and facilitation of synaptic transmission. Okay, so it always it involves increase in number and size of postsynaptic dominance. So please remember that in this there will be increase in number and size of presynaptic terminal. Then next we have long-term basis of memory. So this mechanism of long-term memory is reinforcement of newly formed neural circuits, resulting in consolidation and encoding of memory in different areas of brain. And also this encoding makes memory a permanent for a long-term memory. Okay, so this leads to development of permanent memory. Then last we have the sites of encoding. So various are there like hippocampus, Papage circuit, then hypothalamus, corpus luteum. So these are the main site of memory coding. Okay. So I'm going to write that the various site like hippocampus, Papage circuit, then thalamus, hypothalamus are the site of memory encoding. Okay, and also various areas like frontal and parietal areas are also involved in sites of encoding of memory storage. Okay, so this is all about the physiology basis of memory. So this is all about all the topics that we have covered in today's class. So we have covered Brown-Sequard syndrome, internal capsule, physiology of memory, slow wave sleep, inverse stretch reflex we have covered, then Kluver-Bucky syndrome we have covered, mechanism of conduction and saltatory we have discussed, and also the concept of frontal limb pain we have covered. So this is all about the CNS. So till today means till the third class of CNS, we have covered all the important topics. So if any student have any doubt in any topic, so you can also connect with us through the different platform that is also provided by Auricle. So I hope this class, all the students find beneficial for everyone. Thank you so much for watching my class.